Hi guys, this is Mrs. Gastler, and in this video we're going to talk about graphing techniques. These are good techniques that you want to use whenever you have to graph anything in physics class and on the AP Physics test. Some background, things that you probably already know. The independent variable is the one that you are changing. And this one always goes on the x-axis, okay? And the dependent variable is what you are measuring as a result of your change. You measure, and this one goes on the y-axis, okay? But you already knew that because you have taken a lot of science classes before here, right? If you didn't know, congratulations, now you know. Whenever you are doing any kind of graphing, you're probably going to get a data table, either one that you have created or one that you are given. In this exercise, you're going to be given some data tables. You have a practice that you'll be completing that looks something like this, and it's got some data tables that you'll be graphing. I need to give you a note because there's a typo. Oops, it happens. It'll be okay. Anyway, whenever you're given a data table, generally the X is on this side and the Y is on this side, just to make sure that you know what you're looking at. And when you are getting ready to graph, you want to scale your axes to make sure that you're taking up the entire graph on the AP Physics test. If you don't take up at least half of the graph with your data points, so if you have a data point here and a data point here, and this isn't half of your graph, they won't give you the points for that graph. Same thing for the y-axis here too. It has to take it both of those. If 0, 0 is in your graph, then you just took up even more of the graph by doing that, right? It's actually fairly interesting on how they do that. So they literally counted the boxes. I graded one of those questions recently, and that was what I had to do on all of those graphing. So if you just take up as much space as you possibly can, as large as possible, spreading out your data on that graph, that is what you want to do with your data. Whenever you're doing this, you want to make sure that you are darkening the lines that you are using to represent your axes, so that everybody knows where exactly your axes are on your graph. That makes everything a little bit easier. And then what you're going to do is you're going to make sure that you're going to label the axes with both the name of the variable and the unit. The unit needs to be there as well. See how we've got the unit right here and the unit right there. I don't know why they have two parentheses on those, but they do. That's okay, they can do that. But we have the name and the unit that we've got on our axis, okay? The next thing that we have is a title on our graph. This one is elongation versus force. You could call it whatever you needed to. Whatever's on your y-axis versus whatever's on your x-axis is the fastest way to label your graph, okay? Y versus X is the least amount of words you could possibly use to label your graph. You could go, all out and put a whole bunch of words there to explain what's on your x-axis and what's on your y-axis, or you could just label it Y versus X, okay? But replace whatever's on the y-axis and whatever's on the x-axis in those two spots, okay? Now, once you get your data on the graph, it's necessary to draw a best fit line. Now, I'm really glad that they stated this in the directions. Sometimes it's a line and sometimes it's a curve. If it looks like a line, draw a line. If it does not look like a line, don't draw a line, draw a curve that matches it. On the practice, you're going to have a line and you're going to have some that are not lines, and that's okay. Match it. So if your line looks like this, if your data looks like that, can you see my data there? Zoom in some, see my data? Then I wouldn't draw a line. That's not a line. Look, it's like kind of a Big Dipper, okay? So I would draw something that matches it, but I'm never connecting the dots, okay? Do not connect the dots. Do not connect dots. We will never be connecting dots in physics class. We also will, I can't think of any situations where we're going to be drawing any bar graphs or pie charts. Actually, we might draw some bar graphs and pie charts when we talk about energy, because it's a really good way to represent what's happening. But it's not because we are collecting data and graphing it that way. It's because it's representing what's happening to the energy, okay? Not every graph goes through 0, 0, so make sure that 0, 0 is a necessary place on your graph. You don't always have to connect it back to 0, 0. That's okay if it doesn't go there, okay? So on the practice that goes with this lesson with notes is some data that you're given. You're just given the data, and you're going to need to graph it. Now, one of the practice, the very first question, there's a typo, and there should be a third zero right there. So if you're graphing this data and it's like, what, that doesn't make any sense. You're right, it doesn't. That should be 1,000 and not 100. I'm pretty sure I fix that like every year, but it never ends up getting fixed in the original copy, and so it is still wrong. My apologies. Okay, and so that's it. Thanks for watching.